Hello pre-calc students, Mrs. Fallon back again for yet another riveting pre-calc video. Woohoo! All right, we are on Unit 2 and we are talking about sections 1.3 and 2.1. So we're doing kind of a little, like linear stuff is the 1.3, 2.1 is the quadratics. We're kind of putting both together. This is a review from Algebra 1 and Geometry, Algebra 1 and Algebra 2. So hopefully this kind of reminds you, refreshes your memory, and so forth. So with linear functions, just a quick reminder, we have y equals mx plus b is your slope-intercept form. There are the point-slope form of an equation. This is the one that either one of those would work. So if you're not familiar with that one, I will kind of walk through a couple examples with that. And then of course our standard form equation, which is also called trinomial form. So we got ax plus bx equals c. Negative slope, positive slope, rise over run, all those kinds of good things. Quadratics, we have three forms of quadratics. We have intercept form, and that's where the ones where it's already factored for you. We have standard form, which we've been dealing with. So you should know that your book, or at least the book that our ebook, calls this standard form, and I have always referred to it as vertex form. To be honest with you, this is the first time I've ever heard of this equation being referenced as standard form. But just so you know, in case you're doing some WebAssign assignments, if they're asking for standard form, they really mean vertex form. And then they call standard form trinomial form. Again, I don't know why we have the sudden difference, but nonetheless, those are the forms for the quadratic. All right, so we're gonna go through a couple examples. I'm gonna try to keep this short. So the first example is write an equation of a linear function passing through 2 points. Give your answer in slope-intercept form. So slope-intercept form, what I want you to make sure you understand here is that y equals mx plus b. So step number 1, if you are finding the equation of a line, we're gonna start with y equals mx plus b. We are going to find our slope. So find slope. So when you find the slope of an equation, you can do rise over run if you want, if you're given a graph, right? So obviously here on the side, I was giving you a graph. This is 1, 2, 3 over a run of 1, 2, 3, 4. So the slope is 3/4, but because it's decreasing from left to right, we would call that negative 3/4. Here's another reminder though, probably the better way I like, just because we tend not to forget about the negative signs, if you use the slope formula. So another option is doing the y2 minus y1 over x2 minus x1 formula. So that's the one you should have learned in Algebra 2 or Algebra 1. So again, I'll call this my first point. This is my second point. So I'm going to do 2 minus 5 over 4 minus 0. And see how if I get 2 minus 5, I get negative 3. And 4 minus 0 gives me 4. So again, I don't really care how you use it. I don't think it's worth having to graph a line to be able to figure out the slope. You have a formula you can use. So, use whichever one is easiest for you. In order for us to find the equation of a line, we not only need to find the slope, but we need to find the y-intercept. Well, in this particular problem, did you notice that I gave you the y-intercept? Anytime when x is 0, that's your y-intercept. So step number 3 is find your y-intercept. This one requires 0 work, so my b value equals 5. All right, last but not least, we're going to write our equation in the correct format. So slope-intercept form, so y equals, so I gave you the y equals m, which is negative 3/4 x plus b. Done. All right, let's move on to something a little bit different. So point slope form is probably the one you're not as familiar with. So point slope form is, again, this is how I always write it. There's a couple versions, but this is the one I generally use. So write the equation of a linear function passing through the point and is parallel to the line 2x plus 5y equals 10. Okay, so step number 1 is still to find your slope. Well, if it's parallel to this line, what do you know about lines that are parallel? Okay, you probably think geometrically that they don't touch. Great. But algebraically, what we know is that the lines have the same slope. In order for you to find the slope of this line, you have to put it in slope-intercept form. So you have to take 2x plus 5y equals 10 and solve the equation for y. So subtract 2x from both sides, divide by 5. Now we know our slope is negative 2/5. Remember, your slope is always a number, not a variable. So m equals negative 2/5. So that was step one, find our slope. So we had to use this information to help us out. If this said perpendicular, then we would know that the slopes aren't the same, but they are opposite reciprocals of one another. So again, kind of make sure you're understanding what it is that I'm giving you. All right, step two, you are going to find the y-intercept, but because we're on it in point slope form, we are going to take this equation, we're going to throw in our slope. So all I did here is put in m in for my slope, and now I'm going to take this point and I'm going to plug it into my equation. So I'm going to take this 3 and this 5, this x and this y, and plug it in for y1 and x1. And that's it. So you could leave your answer like this if it asked for the answer in point slope form, but the more common way to write this would be to go ahead and solve for y. So all that means is I would add 5 to both sides. So to move this 5 over here. So this is the equation in point slope form. All right, so that was your refresher on linear functions. Let's jump ahead to quadratics. So turn the page to page 15, where it says quad number 1. All right, write an equation of a quadratic function passing through the point 0, 5, and then with a vertex at 1, 2. Give your answer in standard or vertex form. So standard or vertex form. So again, remember I said about how they write it as standard form, we call it vertex form. That's your equation. So step 2 is you're going to plug in your vertex. So if I know my vertex is 1, 2, that's my h and k. So I'm going to plug in h and I'm going to plug in k. So again here for notes, we pick the equation. This one is you're going to plug in h and k, which is your vertex. Step number 3, in order for us to write an equation in vertex form or standard form as they call it, we need to find the a value. So what we're going to do is we're going to plug in another point to figure out what the a value is. So remember what it said here, the vertex is at 1, 2. So that means our parabola is going to look something like this. Right? It has to be, this is the vertex. I'm going to plug in this point, which was the y-intercept, plug it in for x and y. So plug 5 in for y and 0 in for x. And then just solve your equation for y. So this is negative 1 squared, which is 1. And I get a to equal 3. So in this step, we plug in our point. So it's kind of like our extra point, and we solve for a. All right, step 4, simple enough, is write your equation. So again, your equation has to have an a value, an h value, and a k value. So y equal, I guess we already did the y equal, so we have a, and then x minus 1 squared plus 2. So the final step is to write the equation using a, h, and k. All right, that was a review. Hopefully you remember how to do that from Algebra 2. Another review of Algebra 2 is, we're going to flip the page, we're going to go to page 16, we're going to look at quad number 3. I'm changing the format here, so it says answer in intercept form. So step number 1 is choose your equation. Intercept form, we'll use P and Q for your x and y intercepts. I'm sorry, not x and y, your x intercepts. So take a look at your points. These are your x-intercepts. Why? How do you know? Because your y value is 0. So this is an x-intercept, this is an x-intercept. This is just a point, an extra point. We'll call it an extra point. So what we're going to do is we're going to we picked our equation. Step 2, we're going to plug in our intercepts. So I'm going to plug in 1, so x minus 1. I'm going to plug in 5, x minus 5. Step 3, just like we did in the last problem, we want to solve for a. So we're going to take this point, plug it in for x and y. Just make sure you follow order of operations. So this gives me negative 3a, which I get negative 2 to equal a. Okay, on this one, it said the equation passed. So if these are my x-intercepts, then I know that my vertex is somewhere up here, right? So my parabola has to go like something like this. I don't really care where my vertex is because I didn't ask you for it, but that's kind of what my graph is doing. So does it make sense to have a negative value? And the answer is yes, because it opens down. So then step 4 is to write your equation. So y equals a, and then x minus p and x minus q. So again, if you like to write down the notes, thing is, step number 1 is pick your equation. Step number 2 is plug in x-intercepts. And you're plugging them in for p and q. I don't know why we use p and q, but nonetheless. You're going to find a by plugging in a point. And then you're going to write your final equation with a, p, and q. So that was kind of the process. All right, to be honest with you, those two are really easy. Remember those from Algebra 2. You might not have done this next one in Algebra 2, but guess what? Since we're in pre-calc, we're going to try it. This one is the one where you're asking for your answer in what we call standard form, but what the book is called trinomial form. So what trinomial form is y equals, ax squared plus bx plus c. So it's that format. So that's what trinomial form is. I mean, it is a trinomial. So in order for us to do this, the first thing I want us to understand is that we need to solve, we need to find a, b, and c. In order for this equation to be complete, we need to get a value for a, b, and c. So that's going to be our game plan here. I gave you one of the values. So the first thing I want you to notice is I'm giving you a y-intercept. So think about this equation, right? Your y-intercept is always your c value. So y-intercept equals 0c. So in this case, c is going to equal 1. So whatever your y-intercept is, that's going to be your c value. I'm not going to really give you one that doesn't have a y-intercept until we learn about systems with 3 equations. So we'll hold off on that for now. All right, step number 3, we're going to rewrite our equation. So y equals ax squared plus bx plus 1. Now we're going to take our 2 points, okay? And we're going to plug them in. And we're going to write a system of equations. Sounds exciting, right? So take the point 4, negative 3. You're going to plug it into your equation for x and y. So you're going to have, instead of 4ax squared plus bx plus 1, you're going to have negative 3 equals a 4 squared plus b times 4 plus 1. Let's clean this up a little. So that's 16. And then let's combine any like terms. I can move this 1 over, so if I subtract 1, I get that. We do the exact same thing for the other point. So now I'm going to pick the second point, which is 6, 7, and do the same thing. So plug in 7 for y, 6 for x, and then let's simplify. So I get 36a plus 6b plus 1. I'm going to bump this 1 over. Okay. Here's the fun part. So now we've got 2 equations with 2 unknowns. So we're going to solve a system using these 2 equations. So step 4 is solve the system. So do you remember like elimination and substitution and all that kind of stuff? That's what we're doing here. So what I always do is elimination. So what I do is I choose a variable that I want to get rid of. Do I want to get rid of the a's or do I want to get rid of the b's? 16 and 36 seem like big numbers. I'm not going to mess with those. 4 and 6. I figure if I can multiply this equation by 6 and this equation by -4, I'd be able to get my b's to cancel out. Because this would be positive 24 and this would be negative 24. So that's what I'm going to do. So I'm going to scale the equation up by 6. So if you want to grab a calculator, you can. All right, so we're going to scale the entire equation up by 6. So -4 times 6, I'm just going to write it over here. -24. 16a times 6. So 16 times 6 is 96. And then 4b times 6 is 24b. Now I'm going to take this whole equation and multiply it by -4. So I get -24. I get, what's 36 times -4? I get -144. And I get -24. All right. Kind of running out of room here, but that's okay. So now what I'm going to do is I'm going to add these two functions together. So -24 and -24 give me -48. 96 minus 144, I get -48. And then my b's cancel out. So if I divide both sides by 48, I get a to equal 1. Fantastic. Now I've got 2 of the 3 variables. The third one should be easy to find. So if I go back to go back to this equation or this equation, doesn't really matter. We'll call this step 5. And I'm just going to plug in what I know and solve for b. So -4 equals 16 times 1 is 16 plus 4b. If I subtract 16 from both sides and divide by 4, I get b to equal -5. All right, last but not least, write your equation. Y equals, so again, go back up to your original, ax squared, so 1x squared plus bx, so that'd be like negative, so we'll go -5x plus c, and there you go. That is your answer. I'm just going to highlight that here because there's a lot of work going on here. If you wanted to do that on a separate sheet of paper, I don't blame you. Number 5 that we're going to do in class is going to be kind of similar, so, FYI. So you're going to want to maybe save yourself some space or, write smaller. All right, that's it for this video. Hopefully that was a good refresher. If you have questions, come to class with them.